You're watching another episode of Late Night Docker. All right, I'm going to talk a little bit about Swarm service updates. So if you're familiar with Docker Swarm, it's similar to other container orchestrators in that you can do updates with near zero or almost zero, or possibly even if you're focused on it, actual zero downtime. And I think the industry, we oversell that a little bit, the whole idea of zero downtime updates or rolling updates or blue-green, because it's in the weeds of all that is really actually quite complicated. Now, the orchestrating tools out there make it so much easier. So I've been focusing on Swarm and playing around with this, and I've created some tools, and I thought I'd share some things I've created, some tools I've been using. And so we have Docker Service Update here. This is basically how you go through the approach of taking a service. Maybe it's got 5 containers running of the same image, and you want a rolling update style, change it out. Maybe you got a new version of the image. You want to go from version 1 to version 2. So I was trying to test this in a way that I could teach it and show examples of what the kinds of issues you're really going to have, especially when you go into real world production scenarios where you think that you're just going to update that web app, no problems, and I'm just going to update the database, and my Redis is fine, and my API it's super easy. But there's a lot of subtlety that goes on, and that's why there's a lot of options in Docker, and as well as things beyond Docker that your app needs to take care of when you're talking about ensuring that no connection is lost, and every connection either closes gracefully or at least gives the user a chance to maybe move to a new server. So there's all sorts of stuff like that. But anyway, I created a simple little app. I'm calling it browncoat. The purpose of it is really to give you a very basic web app that gives you a health check URL, so you can get a status out of it, and it returns an HTTP status code, whether the app is healthy or not. And that's really sort of 101 health checks in a distributed application model. If you're doing distributed computing, if you're even looking at container orchestration, you're doing distributed computing at that point because you're already talking about multiple nodes. And if you're talking about an app with multiple containers, you have to coordinate all of that stuff. And so I needed to have an app do things badly. I needed to have an app crash. I needed to have it, and we're not talking about Chaos Monkey, that Netflix thing that does random infrastructure crashing and various things. That's way more advanced than what I'm trying to do here. What I'm trying to do is create a tool that you can use for very simple testing around concepts of how updates need to happen in real time, and hopefully with near zero downtime in your application. So what I needed to do is I needed to create likely scenarios in a production-like setting where you have multiple servers, multiple containers, and things like, what if your app starts up slowly? You know, a lot of production apps, especially database apps, but we're really focused on maybe web apps or more front-end apps, worker-type style apps that you're writing code yourself on, or your team is, the people you're responsible for helping them with their DevOps. That code may get so large that it takes 5 seconds, 15 seconds, 30 seconds. I've seen some apps take minutes, particularly when they're badly configured, and they have caching and sort of all sorts of stuff happening when the container starts. So it takes a while. And so you need to have these health checks in place. We'll get to the health checks part in a minute. But anyway, I needed an app that would be slow at startup, or maybe it would fail immediately on startup, because apps do that when you configure them wrongly, or the dev is quite different than your production, and you put a wrong environment variable into production, things crash. Or I needed it to give a bad health check, right? Or maybe I needed it to crash in the middle of running. Or maybe it's responding to health checks, but the health checks are really slow, because that would be what would happen if your app was under heavy load. And if you have heavy load, then your apps are going to be slow to respond, as well as your health check, and maybe you need to test for that. So I created this simple little tool, and how it works is you're running a container with this in it, and it has pre-built images that are doing very basic things that allow you to do rolling style updates, like version 1 to version 2 of the app and version 2 to version 3. And other things it does are adding health checks. And so when you get into understanding how important in a container orchestrator that your health checks are to the proper functioning of updates, it may not be obvious when you first start out, but once you start trying to change out one container for another container and ensure that your users have a solid experience during that process and that they don't lose connection or you don't have dropped packets or dropped connections, you really need to understand how important the health checks are to your app. And later on in the documentation here, I'm just scrolling through, I have a couple of other nice things in here. You set a lot of these ways that the app is going to misbehave with environment variables in the startup. Now, there's a couple of things here we can do while it's running, and you'll see down here these /fail and the /toggle health check. That'll actually cause it to change in real time while it's running. And then I do something silly. I actually use HTTP status codes to indicate versions. And for a teaching tool, I use that to help people see in real time when we're using tools for monitoring these health checks what the response is and how the connections are being distributed amongst old containers and new containers during an update cycle. So I use HTTP status codes because that's an easy way to get back from tools what the code is. And so when you see an HTTP code of 201, for example, that means you're running the version 1 of my image. If you see the 202 status code, you're running version 2, and so on. So let's jump in. I've got a 3-node swarm here. I'm actually using Docker Machine on my local laptop. And if I just do a Docker node ls, you'll see that I have 3 nodes here. And we're going to first need to create a network to do this testing, just so that we have it set to attachable, which is an option in Swarm to ensure that our network can be connected to from individual containers, not just Swarm services. And so we do a Docker network create. And I need to specify the driver overlay, which is the swarm-wide driver. And attachable. I'm going to call it verse. All right, and then we're going to create our service. So this is going to be the browncoat web server and Docker service create. In fact, let me get this a little larger. Docker service create, name, I'm going to call it Firefly. We're just going to put this on port 80 so that we can at least see that the web app is running. Put it on that same network we just created, and we're going to give it 5 replicas. And we're going to run the image, Brett Fisher, browncoat. And we're going to start with the version 1 image. So we'll give it a tag of version 1. And we'll spin that up, and that'll start 5 containers on the 3 nodes that I have. And then I'm just going to jump over real quick and show you. So this would be the front page. It's not meant to be anything fancy. It's a node.js Express app with bare minimum functionality. But you'll notice in here that we have this health Z route. So I've built in a very simplistic health check. And I recommend that if you're not doing that today in your applications, that you invest time in that, because this really helps with monitoring and rolling updates and all sorts of stuff in your app to just build this kind of tooling into your app natively, especially for distributed systems and microservices. So you'll see here that I have some very basic JSON array data coming out of there that just shows me basically the settings that I've set on startup. Now, we didn't change any of those settings out of the box, so it's running with the default version 1 status there. And I'm not using a health check in Docker. So Docker doesn't have any true awareness of what's going on in my app. It just knows that the binary is running. And if I do a Docker service PS on Firefly, we get a list of those 5 containers running. And let's move on. So the first tool I want to talk about here is HTTP ping. I'm going to mess that up, by the way. HTTP ping. It's hard to say. HTTP ping. I say it really fast. So it's not actually HTTP ping. There's only one P. So I'm assuming it's called HTTP ping. And I'm using my own container here. I just build it from source, from the actual author of this tool. And that way I can run it inside my swarm as another container testing on the overlay network that we're using. And what I want to do here is I want to get and if you haven't ever used HTTP ping, it's very similar to it functions similarly to ping, but it's using the HTTP protocol like curl would use. And that's a much better test if you're using web apps or web APIs, because you want to actually test against the real application itself, not arbitrary pings, which are a totally different protocol, ICMP, not related to your app in any way, and may not even work depending on the network layers involved and how things are set up. So let's use that. I'm going to do a Docker run here. Actually clear the screen. I'm just going to do a --rm to clean up after we're done here. Now I'm going to attach it to that same network and run the HTTP ping image that I built /HTTP ping. And this image is expecting to run, it runs HTTP ping out of the box. So I don't actually have to type anything after here. I could just type the URL. I don't have to type HTTP ping again because that's really the only binary that this image is designed for. So what I want to do is give it a couple of options though, because out of the box it doesn't connect but once or twice a second. So I want to give it a -I for interval. The interval is going to tell it how many times a second I want it to, and I'm telling it 0.1, which is 100 milliseconds. So I want it to give me 10 times a second. It gives us a better experience in testing because rolling updates tend to happen fast, especially on the small app like we're using here. So the other three options I'm going to use are capital G, lowercase s, and capital Y. The G uses a get instead of a header request, a head request. The S gives us status codes. It gives us back the status code so we can see that 201 and 202 status codes coming out of the URL. That'll make sense in a minute. And then the Y is for color because color is pretty and I like it. So let's give it the URL. It's actually going to be the name of the service, Firefly, and then the health is the URL. And then this is going to fill our screen with what looks like pings, and actually it says ping, even though it's not really the ping protocol. And I'm going to shrink this down. You'll notice on the right, the green part's one of the important parts. That 201 you'll see there is actually what's telling us that we're running version 1 of the image. So as we roll into the version 2 of the image, that will change to a 202. It gives us a simple little visualization of how the connections are being distributed as we go through a rolling update style update. I'm going to bring up another terminal here to do the update on. Docker service update. I'm just going to do the same image, but we're going to do a different tag. And this time we're going to do v2. So we're going to roll update into the version 2 image. We're going to do this against the Firefly service, and away we go. Now this is default out of the box, no health checks, nothing like that. Now you'll see that there's a gap there. That's it missing a connection. We'll explain why that's happening in a minute. Now there's another one. So we got a couple missed connections. So we're not actually zero downtime at this point. There's a third one. If I was pinging it more than every 100 milliseconds, I'd probably get a lot more failures. All right, and now you can see that the greens are all 202. So if you noticed, it was because Swarm's virtual IP of a service, the VIP, does a round robin style in the background. It's sending each new connection to the next node in the 5. And so if you were able to pay attention quickly, you would see that as it replaced the first one, every 5th connection was a 202, and then 2 out of 5 connections were hitting 202, and that's how it goes through. And the description on the right with the detached being false, we get to see that on the right. That's a pretty simple explanation, but we're able to validate that at least a little bit on the left there. So why did we lose those connections? Well, to explain that more clearly, we can do that same command, that same update. We'll go back to version 1, but we're going to give it an additional environment variable this time, env add, and I'm going to set, you can actually see this on the documentation for the browncoat image. It's also in the GitHub repo, but we do go down to the settings. The delay startup will force my application to act as if it's slow to start up. And so many apps don't start up in a second like this one. So this is out of the box express. There's very little to it. So it's going to start up about as quick as Node can start up, which is about a second or so. And most apps are not going to start that fast. So let's delay this 5 seconds. So I'm going to give it a delay startup 5,000 milliseconds. And we're going to do the same thing over. And we're changing back over to the first image again. So we'll start seeing the 201s coming into play. And look at how many connections I'm getting refused here. This is key to understanding distributed computing updates. Docker, out of the box, without that health check, doesn't know whether my app is ready for connections. And so when you were using Docker Run and Docker Compose in your local machine, you didn't have to care about health checks. And in production, you might use a third-party tool to monitor your applications, and that's fine. That's not the same thing as a health check. And in fact, I would argue you need both, right? You need a third-party advanced monitoring solution because Docker is not going to, Docker Swarm's health checks and monitoring features are not meant to solve all your monitoring problems. But those health checks are there for an additional reason, not just to help you know basic status, but it's to give Docker the awareness of whether your app is ready for connections. Other orchestrators like Kubernetes do this as well. Docker has the one health check in the latest releases, and it's either ready or it's not. But when I don't have the health check, it's only going to know that the container started. And so it doesn't have the intelligence to know that my app took 5 seconds. And during that 5 seconds, it was sending connections to each container that was new, thinking they were ready when they really weren't. And that's how we lost those connections. So if you saw in the lines there, the gaps, those lines were connections that were lost. All right. So we can add a health check in, and we don't even have to add it to the current situation. We can just add the health check into the next update cycle, and it will help give that awareness. So if we did that same delay, but I changed the version to an image that I know has a health check in it. And if you don't know much about health checks, you can add health checks to Docker files. You can add health checks to the update command. You can add health checks to the create command for service creates. You can add them in lots of places. You can put them in compose files for Docker stacks. So there's lots of ways, but they ultimately all do the same thing. They're running on your inside of each of your containers the command you tell it to run. And in this case, if you actually went to this browncoat image, the Docker file, let's go back over to the image. The Docker file has a very simple, it's actually, this one's only going to show me the default Docker file. Let me go back over to the repo. The repo has lots of Docker files, one for each image to keep it clear exactly about what's happening here. And what we're going to do is we're going to update to the Docker file with the Docker file image with with the health check included. And so the only difference of this image is that it has a health check built in. Now, I could type the health check command in the command line. I don't want to do that. It's tedious. So I just had this image ready with the health check in it. And watch how different this goes. So I had the delayed startup still at 5 seconds, so I should be losing lots of connections. But if I just choose the new image to be the health check one, Docker will pull down that image and see that the image itself in the metadata has a health check command. And as it starts adding these new containers, you'll notice it's starting and it's waiting longer before it considers it running because it's waiting for that health check to be green and to be ready. So it's going to take a little bit longer because my app is taking longer to start. We didn't really time these things, but it is going to be slower. And so you'll notice that my ping times you'll see that sometimes they're actually more than 10 milliseconds. And I think what that is that's one of the first times that the container, as soon as it starts up, it's getting new connections. And it takes a little time for the JavaScript to spin up in the background and cache some of that stuff into memory. And we're almost through it. We're at the third one. Now we're at the fourth one. And you don't see the 201s changing because we're unfortunately changing from a version 1 to a version 1 with the health check in it. So we're not going to be able to see that visualization on the green labels on the left. But we're almost done here. And you'll see that we haven't lost a connection yet. And that's because it's waiting for that health check to be green at least once before it starts sending connections to that container. All right. And now it's going to do its verification where it sort of waits for the health checks to be valid across the board, and we're good to go. And cool. We've taken that app that previously was losing connections on updates. We've added a simple health check to it. Again, we can look at that health check over here. It's not requiring any application code. It's simply hitting my health URL. If you didn't have the health URL, you could be hitting just a standard URL that you know always is going to work in your app until you actually get you instrument your code there that actually has more intelligence to it. So I'm using a simple curl command here. Once you get more advanced with health checks, there's a whole other topic on this. We could talk for days where you might want to use intelligent health checks where you're using Node to actually check itself, and you're using Node JavaScript data that's much more intelligent and much more in depth than a curl command might be. But in this case, it's a simple example. You'll see that I've thrown some options in that it's going to do it 3 times before it considers it down. It's going to try 3 times before it considers it failed. Its interval is every 5 seconds, so it's not hitting it every second because that might be too much on your app. And the start period, I give it 10 seconds to start up. So that's it for this little quick demo. There's a lot more about this stuff coming in my course. This is actually a new module, a new section I'm creating on all the different nuances of updates, health checks, and more. And I hope you check it out, and I'll see you in the next YouTube Live.